Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. Analyze each compound for unique hydrogen environments, excluding stereoisomerism for column 2, including for column 3. A. The structure shown as two fused rectangles is bicyclo, 1.1.0, butane or more likely to fused cyclobutane rings, bicyclo, 2.2.0, hexane bicyclohexane. However, given the answer A, QX, to structural, 3 including stereo, this is consistent with a structure having two sets of unique H environments structurally but one set giving a chiral center producing stereoisomers, yielding 3 total including stereoisomers. B. 2-methylbutane, CH3CH, CH3, CH2, CH3. H environments, excluding stereo C1, CH3 on branch, 6H equivalent by symmetry. No, C1 is CH3 to CH, so the 2 CH3 on C2 are equivalent is equal to 1 type, C2H is equal to 1 type, C3H2 is equal to 1 type, C4CH3 is equal to 1 type. That gives 4 structural monochlorides. Including stereoisomerism, chlorination at C3 gives a chiral center, CHClCH3 next to CH, CH3, 2, so C3 gives R and S is equal to 2, C2 already has 4 different groups when Cl replaces H giving chiral center is equal to 2 stereoisomers, C1, either of equivalent CH3 groups, is equal to 1, C4 is equal to 1. Total is equal to 1 plus 2 plus 2 plus 1 is equal to weight. Let me recount. Positions, C1, the 2 equivalent methyls on C2I, CH3, to group, 1 product, C2H, 1 product, chiral, gives to stereoisomers, R plus S, C3H2, 1 structural product, chiral center created, gives R plus S is equal to 2, C4CH3, 1 product. Structural is equal to 4, S, stereoisomers, C1 is equal to 1, C2 is equal to 2, C3 is equal to 2, C4 is equal to 1 is equal to 6 total, Z. So B S Z. C, 2, 2, 3, 3, tetramethylbutane, CH3, 3C, C, CH3, 3. All 18 H atoms are equivalent, all in equivalent CH3 groups. Only one structural monochloride, P, and no chiral center is created. The product is CH3 to ClC, C, CH3, 3 which has no chiral center due to 2 identical CH3 groups on same carbon. Actually CCl, CH3, 2 C, CH3, 3. The carbon-bearing Cl has CH3, CH3, C, CH3, 3 and Cl, 2 identical CH3 groups so not chiral. So 1 including stereo, W. So C, PW. D, N-butane, CH3, CH2, CH2, CH3. H environments, excluding stereo C1, C4 equivalent CH3 is equal to 1 type, C2, C3 equivalent CH2 is equal to 1 type. So 2 structural monochlorides, Q. Including stereoisomerism, C1 chlorination, CH2Cl, CH2, CH2, CH3, no chiral center is equal to 1, C2 chlorination, CH3, CHCl, CH2, CH3, chiral center created is equal to 2, R and S. Total is equal to 1 plus 2 equals 3, kiss smiley. So D, QX. A. Revisited, the fused rectangle structure given A, QX, same as D, this must also have 2 structural and 3 including stereo. This is consistent with bicyclo, 1.1.0, butane or a similar small bicyclic compound with 2 types of H, bridgehead versus bridge, giving 2 structural products, and one of them generating a stereocenter giving 3 total. Therefore, the correct answer is A QX, B SZ, C PW, D QX. Therefore, the correct matching is A matches QX, B matches SZ, C matches PW, D matches QX.